I'm Kanchana. I am a director of data science at Kinaxis. Until a few months ago, I was part of a startup called RubyCloud. We were a machine learning AI startup for CPG and retail related problems that included anything from demand forecasting, promotion optimization, and so on. And right now we've been acquired by Kinaxis a few months ago, and Kinaxis is a supply chain planning company. It's a software company that developed a tool for supply chain planning. And we have become the data science and AI, a big chunk of the data science AI wing of that company. And we're right now continuing to solve our CPG retail problems, as well as trying to expand out machine learning and data science into other verticals, such as life sciences and pharma, etc., as well as try to bring in machine learning data science into the supply chain planning process. So that's kind of where we are. It's very exciting, especially with COVID. I think it really threw all of our models completely off. Like planning for retail and CPGs during COVID has been impossible, if not very, very hard. So.
Do you think that trend is changing now that COVID is, I guess, the impact of COVID is starting to lessen?
I think what we've seen is that right now, at least, we have enough data points to start testing things. I think, when customers would come and ask us in May, hey, what are you going to do about COVID? We're like, we actually don't know because we don't have enough data. Like we don't know what the pattern looks like. How can we model for it, right? So I think we were just now starting to gather enough months of data so that if we make a change, we can start testing and seeing what it looks like. And for sure, things are better now in the sense that some of the techniques we're using are working. But the question is, what happens in the future, right? I think this is something we have to be constantly monitoring until we know. Like, I think it's probably going to be a year where we're going to be constantly doing these changes and upgrades until things kind of stabilize. But at least it's better now than it was in May, when I was like, I have no idea what do you want me to do? Like, I don't know. It's not a data science problem at that point. So.
Absolutely. So we have a question from Dia here. What are the main challenges that you have to deal with within your role? I
was just thinking about what. I think there are a few different avenues. I think one of the hardest pieces is obviously, in some ways, explaining what you do. In terms of sometimes machine learning and data science is misconstrued in some way as an oracle, where you should be able to predict anything, right? Like, why is this particular thing not correct? But then we're like, we can only do things that are in the data. We learn from what's already there. It's not that we are kind of creating new things, right? So the challenge is always when we have to explain what we're building and what machine learning can do versus what it cannot do, right? I think that's always a constant challenge, just in terms of the job. But I think in terms of the work itself, I think productizing machine learning is a really, really hard problem. In terms of getting a product going for machine learning and having it consistently deployed across clients is something. It's a constant learning for us in terms of we have a product, we've deployed it, but then the next version looks a bit different. We have to make a little bit more tweaks. We have to make a little bit more changes so that it can be deployed to more and more clients. Because at the bottom line, most people care about the results, right? Like, the results have to be accurate. They have to be good enough. As much as you have a fancy system, you have everything around it, but the bottom line is, if the results are bad, then nobody cares about data science or machine learning. So I think in order to keep up that and make sure that we can still scale and still deploy is a constant challenge. And I think it's something we're facing now. I think many companies are facing it, and I think we don't have a golden standard of how to solve it. So.
Absolutely. Yeah. And then we have another question here from Helena. It's essentially, how have you dealt with mental strain associated with trying to live up to a professional idea originally created from Stifle rather than support gender and diversity?
That's a very loaded question. Maybe I can question
it. Yeah, so maybe start with the professional.
Yeah, I think it's, I guess it's probably a little bit around the imposter syndrome as well, probably around. So it's stressful in the sense that I'm big on the imposter syndrome, I think. So every time you have a big meeting, you're always questioning yourself in terms of like, can I do it? Like, am I good enough? Am I going to be giving? I have to be the data science expert, but am I truly the expert? Am I giving all the right answers? Am I promising things that my team can deliver, right? Like, or am I not? Am I saying something completely nonsense? So I think I go through that strain, all the time. I think, as someone who has it, I think I am someone who goes through it a lot. I think for me, the two avenues that have helped me is one, is to just forgive yourself. I mean, if you make a mistake, it's okay. Like it's all right to sometimes not be right all the time. It's okay to forgive yourself. It's a hard learned lesson to give up and say, okay, at the end of the day, I'm going to forget what happened. I'm going to be able to say, let it go. Okay, so you said something wrong, so what, right? But the second piece of that is always, I think back to things that I feel good about, things that I've achieved in my life, things that I'm proud of. And I always think, oh, if I've achieved those, and I'm probably done something right. Like, obviously, I'm good enough that I've achieved all those different things. How small they are, and everybody's achievements feel and look different. It's just, when I look at that, I feel happy. And when I feel happy, automatically, that piece goes away. And I'm like, oh, okay, clearly I've gotten a PhD, so maybe I know what I'm talking about. Like, so it's a little bit of that as well. Like, like kind of thinking, going to a happy place, thinking about things that make you feel like, you've achieved things. So that's part of it.
Yeah, absolutely. I hope all of you can definitely feel free to essentially turn on your webcams and essentially ask the questions as well. But we do have a question from Dia, and then we'll jump onto the question from Gadari as well. So this question kind of ties into essentially the imposter syndrome is, how do you balance the technical and the non-technical parts of your career, and especially earlier on in your career?
Yeah, that's a really good question. And I think in data science, even very early on, you do have both, because you have the challenge of trying to build your machine learning piece and trying to build your solution, but then you also have the challenge of explaining what you've done and explaining in a way that people understand. For me, it's purely been through practice. You just try it a few times, and you get feedback early on. You get more feedback from people you trust, like people, my manager or my peers who I know understand what I'm saying and will be able to challenge me, and be ready to accept that feedback. Like, because the end goal is, you want to make sure that the piece of work that you've done is accepted and goes into the product. That's your end goal. It's not really about how right or how wrong you were when you started. It's just about how right you are when you finished. So I think for me, it's been a lot about that early on. But I think now, and as I said before, is in terms of managing the technical and non-technical pieces, is I'm a manager right now. So for me, my team becomes very important. Like, making sure that they are successful becomes very important. And sometimes you have to give up on some of the technical things that you could have done. Like, of course, I want to work on the next awesome thing that my company is working on, right? But it's not possible. I can't work on it. So I work on it vicariously through my people, where I'm like, oh, they're doing these cool things. I'm going to sit in, I'm going to brainstorm with them. I'm going to get ideas, but I know I'm not going to be the one implementing them, right? So for me, that's something that I've had to accept. As much as I love the technical piece, I've also really loved management. I've also really loved mentoring. And so I've chosen to take more of this side of things. And it's just more accepting that that's okay. So.
And it's just like, I guess, changing your prioritization more or less,
Exactly.
In terms of saying, okay, you're going to prioritize your team over
Correct.
there. Yeah, gotcha.
Correct.
Cool. The next question we have is from Ganjari. And this question is, do you have a favorite go-to machine learning model?
It's funny, I actually asked that in my interviews. So for me, I think the simplest solution is always the best. So like at the start of a project, I will never run a deep learning model. I will never run it. Like I will try to avoid running it as much as possible unless I absolutely have to. But I have to say my favorites have always been tree models. So like GBM would now be one of my favorites, just because over the time that I've used it, I've always found it to be quite versatile. It's worked for many of the problems that I've personally worked on. So for me, that's a favorite, but it really, obviously everybody knows it really depends on the problem and what kind of solution, but I would prefer the simpler solution every single time. So,
and
like if a would work, then please use the moving average. So that's what you should do.
Gotcha. And what would be some, I guess, application usage of that model?
I mean, it's a general classification regression model. So pretty much any kind of predictive modeling can be done using that model. It's actually quite popular as well because one, it has inherent ensembling, so you can build many. So it's not one single model, but it's an ensemble of many different models, and ensembling models have always been shown to work better. But in general, I think across my career, across different problems, it's just worked very well for these kind of predictive models. So the kind that I personally work, the simplest example I can give is just forecasting the number of units a particular SKU will sell. I think it sounds like a very simple problem. It's an extremely complicated problem given the data that we have from all the retailers. If you think of the number of retailers there are, you can think of the number of stores they have. So even at the complexity of all of this data, this model is pretty robust and has worked very well. So.
Yes. Nice. Commenting on low unit cost use cases don't play well. Does anyone have any additional questions? No. All right. I've got some questions. Maybe do you have any advice in terms of how can you differentiate yourself as an individual that's wanting to go into data science?
Right. Maybe okay. So I think the first piece, just like very practical advice would be, I review a lot of resumes. And when I see projects on the resumes, I see the same three data sets, like the Titanic data set, the house prices data set. I see the same things over and over. And at this point, I think we've gotten immune to that, where we just skip through that because we've seen those data sets. It's a solved problem. People have done it over and over. So I think what would be interesting is to see things that are not those common data sets that everybody does in school. Maybe some other, other Kaggle competitions that are not so common. Maybe some other data sets out there that are not as frequently used. Just even a quick analysis on that and some work on that would be very nice. Of course, if you can create and put it on GitHub, that's quite useful because then we can see your work on it. One no-no for me would be don't create a GitHub link where you've just forked a bunch of repos and have done nothing with it. That's a big no-no because all it shows nothing, frankly. And I do click on GitHub links because I'm curious. I want to see people's code. For me, coding is really, really one of the key skills that a data scientist can have. So when I go and see that skill, it kind of really annoys me when I just see forked repos with no work done on your own. So you fork a repo and work on it, but then just don't have a bunch of forked repos on your GitHub. I think that's important to me. In terms of another differentiator is just in your career advices, try to say yes to as many opportunities as you get. So for me, teaching was an opportunity I got. Like I always enjoyed teaching, but then I think in 2015 I got the opportunity to teach. It was for one semester, but then I've been teaching since then. So I've been teaching both at Ryerson and UFT since then. I've kind of had to make time for it between everything else that I'm doing, but I've really enjoyed it. I think for me personally, it has really enriched my career. And being on panels, right? You can always say no because it's a work time. You have to spend time on it, but you get to see so many perspectives, and you're here. And I've listened to other wonderful women in my space. So I've said yes to it. So try to say yes to a lot of these opportunities, technical opportunities that you get, however small it may seem, because you really don't know what will, like I said yes to teaching one course for one semester, knowing very well it's going to end in one semester, but I had to create the course, but then it's now gone on for like since 2015. So you never know what's going to teach you to that, what's going to give you the next opportunity. So.
Absolutely. Absolutely. So we have another question here from Gadari, which is, what are the qualities to look for in a candidate when hiring?
Right. I think I just talked personally about the team that I hire for. So I have a very technical data science team. So the kinds of things technically that I look for is machine learning experience, of course. But as I say, specifically people who can learn under the hood, like know what's happening, under the hood in terms of what is the algorithm doing, how is it working, not just about running functions, because I think that's easy. Like these days, getting a package and downloading a Python code and running it is easy. But even if you learn, you don't obviously have to learn all of the 100 algorithms that are out there. Nobody knows that, right? Like if you tell me you know it, I'm going to think it's fake. So even a few things that you can focus on and kind of learn what's going on under the hood, I think will take you very far. The second piece is obviously coding. Definitely, Python's the go-to language, but any coding, any language of your preference, be good at it, because one, it gets you, it makes you a good data scientist because you can program and code things really fast and prototype really fast, which is what your company will look for. But then in many cases, like it's the case in my team, where we have a product, but then the data scientists themselves code things into product, because some of the solutions we build are complicated enough that it's easier if we just are able to code it rather than telling someone else to get it into production. So I think that's a very useful skill to have as well for me, those two technical skills. But then the third piece is what I alluded to before, is just getting into the practice of explaining what you do very simply, right? Like what are your results actually saying? Not that I have 70% accuracy, but exactly what does 70% accuracy mean? What does 30% accuracy mean in terms of the business context? Like what problem are you solving? So what does 70% accuracy mean in that context? So I think those are, important qualities for any data scientist, I think, and even in the context of my team.
And then I guess how important would you say it is for an individual, for a data scientist to have experience in productionalizing the models that they're creating? Because I have come across a lot of data scientists who have experience, but they don't necessarily have that experience in productionalizing that sort of stuff.
So that's usually learned on the job. It really depends on if you've had a chance to do it or not. For me, in my very, very first job, I was in a data science team where we were 3 people. There was my boss and 2 of us, and nobody else in the company knew very much about data science. So anything we build, not only we had to put it into production, but we also had to be the support person. So I've taken calls late in the evening, acting as that IT support person who will handle, an issue. And when we deployed the Hadoop cluster, and we put some data science on it, I've taken calls where, I've had to restart the cluster and do all of that because not many people knew it. So it's really depends on what kind of experience you come from. I usually don't look for that specifically because I know it really depends on what role you are. But it is something you can learn on the job, and it's just purely if you do it a few times, you kind of know how it is, and you have to be in an environment where that is happening often. So
absolutely,
it's not. It's very hard to learn from a textbook, I think.
Absolutely, agreed. Yeah. So there's another question from Helena, which is, what are your thoughts on going back to academic after?
Right. For me, so right now I do both. Like I teach and I mentor students in academia, but then I'm also in the industry. For me, I like this balance in terms of, for me, academia gives me that avenue to explore new things with my students and to be able to teach and to give back in some way. And I've always enjoyed teaching. But being in the industry kind of gives me that opportunity to deploy something that may not be as technically challenging in terms of, it's not the academic research level of, crazy new things, but then it at least gives me that chance of seeing something in production, seeing something that people will use and getting that feedback directly from people who use. And in some ways, the industry also helps me keep in touch with a lot of the latest things that need to happen, because often, when we've had to scale and make your pipelines and stuff run faster, run better, you're always looking at the next thing that can help you do that. So in some ways, industry also helped me be current. And I think one helps me do the job better. Like teaching helps me explain myself at work better, but then industry gives me all the inputs that I need to teach better. So I can talk about real life examples to my students and when I'm explaining, so it's not really theoretical at that point. So I would find it very hard to choose one or the other. For me, I would always have to be in that balance of both.
And I guess another question is, how do you balance between the two? That's an interesting one.
It's definitely not easy, especially when it takes commitment. In the sense, I've had to, I think in my career, create a lot of courses from scratch, which anybody who's taught before and created courses knows that it's a lot of work to create a course and create the material and create the assignments. And as hard as it is for students to take a course, it's a lot more work for teachers to actually create all the material. For me, I just enjoy it. I love it. So for me, it's not painful as much as if I'm spending late evenings doing it. I'm tired at that point, but when I'm in class and when I'm teaching for those 3 hours, it's fantastic. I get a high when I'm teaching. So because I like it, I do it. So the day I'm tired of it, I'd probably not do it anymore. So
yeah, that's a good way to put it. We do have another question from Ruben, which is, do you have a preference for PhDs when hiring for data scientists?
Not particularly. In fact, my team does not have all PhDs to start with. For me, it's really more about the skills and what you bring to the table, and and going through the rounds. So I have a screening interview where I kind of get a sense of where you are, who you are, and what happens. And then we have a few other rounds where we test the skills that we want to. Oh, the one skill that I did forget to mention before, which is SQL. So definitely learn SQL. Like, it'll serve you very, very well, whether you're doing big data with Spark or whether you're doing just plain RDBMS. SQL is something that's another thing that I definitely look for. So I just forgot to mention it when he asked the question. I remembered. So for me, there's no preference. I think for me, it's just about what your resume tells me in terms of what you can do initially. And then from then on, it's just what you do in the interview.
Yep, nice. And then we have a question from Abhishek, which is building on to the question that was previously asked. Do you think a formal degree in data science and machine learning is important for you to hire a candidate? I think you've sort of answered that, but.
Yeah, not necessarily in the sense that my team is filled with anybody from astronomy majors to astrophysicists to pure physicists to computer scientists to a biotech. So I think I have a lot of different variety of people on my team. I think the key, like I said before, is not so much what your background is as much as with machine learning and stuff. Do you understand what's going on with the algorithm itself? Do you understand what's happening under the hood? Because there have been times when I've interviewed people who know scikit-learn inside out. They can run all the functions, but when I start digging into details of, hey, what does logic regression really do? Like, forget about this coding piece. Let's on a piece of paper maybe try to explain what this does, and then that's when I've seen them falter, which is the piece that you should focus on, And I said, like I said, it doesn't have to be every single algorithm on the planet. Like, it just has to be a few things so that it gives you a chance. It tells me that, hey, if something new comes, that you'll easily pick it up, and there's no reason why you won't. So I think that's really it for me.
So it's a balance between understanding the as well as the practical.
Correct.
Perfect. So there's another question from Ruben. It's, what percentage of focus do you dedicate to solution relative to the modeling approach?
I'm not sure if I got the question, but maybe I'll try to answer it. So I assume he's talking about the end solution versus the exact modeling approach you're using. There are actually a couple of points here. So as I said before, I think the simplest approach that will work well is good. It doesn't mean that more complex approaches are not appreciated. It's just that if there's something simpler that would work, you want to go for it, because data science is not just about prototyping and showing results. It's about taking that to production, making sure it can work at scale, because once a data scientist develops it and puts it into a product, that product is going to be used by many, many people. Often we're generating millions of records every single day. And if it takes a long time to generate one record, it kind of defeats the purpose. So you're thinking not just about the modeling approach itself, but exactly how will that work in production, at what scale, how fast can it work, and there are lots of other pieces to the puzzle. So for me, of course, the modeling approach is very important, but I think it's in the context of what you're building it for and how it's going to get used. So I think both of those are important. I don't like one specific modeling approach over the other. It's just whatever works. And it also comes from people's experience. Some people have used a particular model a lot. They like it. They want to try it because they really know that well. Some people, like I said, the only things I would try to avoid is going for more complicated things like deep learning at the beginning of a project. Like it should be more of a thought out plan of why you need something like deep learning, why should you be using it. So I think that would be my only advice.
Awesome. Thank you. Any other questions?
Give me 1 second. Let me pull my charger up because my laptop is...
Yeah, absolutely.
Sorry. Yeah, there you go. Yep, I'm back. Yeah.
Yeah. Okay. I guess I have a very generic question for you, just because, oh, looks like there's more questions on balance. Okay, so we do have another question. How do you balance work and life outside of work? And I guess especially with COVID and amongst COVID.
It's tell me about it. It's been, I think, extremely challenging, I think, for me personally, because I actually was on mat leave when COVID started. I was actually going to restart work third week of March, and that's the week that everybody went completely remote. So I started back at my workplace completely remote with a 1-year-old who could not go to daycare because daycares were closed. So that's how, and we had a client escalation 2 weeks later. So I think for me, it's about me and my partner, me and my husband, kind of taking that turn, because obviously we try to schedule our meetings in a way that one of us is available. We try to plan around, we plan each other's days together, so that we can balance having my daughter at home and for us to work. I also make sure that I kind of lock after 5. Like at 5, I'm out. Like I don't schedule meetings before 5. I definitely don't schedule meetings before 9:30. So I kind of make sure that think people are not creeping in on my personal time. And usually after 5, I log out. And if there's really anything urgent, I kind of look at it after I kind of spend some time with my daughter. I put her to bed, after about 8, whatever, whenever she's in bed and fed, I kind of do that. And I also make sure that my lunchtime, I try to take time off so that I can make sure that I can work with her. I give her lunch and kind of do that. I've also become more efficient because I think I wake up in the morning, I have to cook for my child for the day. I have to make sure she has breakfast and she has everything ready for the day, and then take like a 15-minute recess in the middle so I can, get her afternoon snack ready, because, I don't want to chop her fruit early in the morning because it gets by the afternoon. So I kind of make sure I take a little bit of time in the middle to do that. So it's been a lot of juggling of work and a lot of support from my husband in terms of making sure that our meetings are not coinciding. So it's been very challenging. Like, I'm not going to say I haven't figured it out. I'm still every day trying to see how to do it better. So, okay, I think we've lost Asma, but I can see a question here. It says, given the cutting edge developments primarily in C and NLP, how do you keep it motivated to focus on simpler and more classical applications? Personally, I think it's just about experience. I think obviously when when you just start working in this field, you're more excited to work on the newer pieces. But I think as time goes by, as you start working on real life problems, you understand that having trying the most simpler approaches is what is the way forward. Also because simpler ones are the ones that you can iterate faster, because often the key to data science is getting the first result really fast, so that then you know what the issues are, and then you can iterate, and then the cycle, the time to iterate should be really, really quick, so that you can make tweaks and changes, and then you can get your output. So I think the key is always that piece where you know once you know that that's the cycle you're expected, you kind of naturally gravitate towards the more classical or simpler approaches. That being said, I think you also want to give an avenue for a researcher, the data scientist in you, to explore new things. So I think it's a balance of practicality versus giving some time where people can explore new things, people can bring in new things to the table, because that's how you learn stuff, right? You won't know something works until it works. So I think it's just a balance of making sure that you can, people are practical about data science, but then you also give them an avenue where they can explore new things and then bring that to the table. So I'm not averse to having new things. It's just you just need to figure out what's working and then go for it. So.
Absolutely. It looks like we have one more question. I think we'll probably have time for one last question, more or less. So this one is, given that there's cutting edge developments, primarily in CD. Sorry. Oh, I'm so sorry. I think I must have disconnected.
No, no worries. It happened to me. I couldn't find the share video button for the longest time. So Tina had to get on a Google chat with me, and then we had to restart my computer to do all of that. So it's
gotcha. No worries.
No worries.
Okay. So there's one question that just came up. It's how to effectively convert a business problem into an ML problem.
There's no golden bullet to do that. The main question is ask a lot of questions. Like try to get to the crux of what they're looking for. Because sometimes, when a client or when a product manager comes to you with an ask to say, okay, this is the feature that they're looking for, they're probably at a very, very high level. So you want to dig in to not the what, but exactly not the what in the sense, not just, hey, this is the problem we're looking to solve, but exactly what are you trying to solve? Like, what is your pain point? Like, what's the solution? What does the end goal look like? Because that's what helps you design the solution. Sometimes what they're asking for may not necessarily be what they're trying to solve, because they think it'll solve it. So for me, it's always been asking a lot of questions and always being on point about what is the end goal? What is this particular feature going to do for you? Because you tell me that, and then I can give you a solution, right? I don't want you to tell me what the solution is. So it's always a conversation with sales, with product, because they bring a lot of client perspective and they know the pain points that they are facing. But then for you, it's just about getting to that bit about exactly what is that pain point and exactly how is it going to be used. And that's what tells you how to solve it. But there's no like step-by-step approach to getting to an ML solution. It's just about lots of conversations.
Got it. And there's a question here from Linda in regards to recent research papers or regarding algorithms and use cases. Do you have any, I guess, maybe any generic, I guess, your favorite maybe cases that you visit just in terms of getting those research papers or just sort of looking at it, or any sort of links or any sort of, I guess, books even?
Right. For me, it's I think I do enjoy the research papers here and there, and especially when my team tells me, "Hey, you should read this. This is really interesting." Especially there have been a few specifically on Google that Google wrote, which I can probably find the link on building out machine learning systems. I think that's been the most fascinating thing, the recent, because solving one problem and solving one particular piece of the puzzle is great. Like, okay, I can prototype and solve the problem on a notebook, right? But what does that mean, and how do you build out a system that can deliver it consistently to the client or to an end user? I think is a really fascinating area of research. I don't think anybody has particularly solved it, I mean, as a golden standard. So Google has a lot of work done on it, and they have papers on it, which for me are personally, I think I find them very interesting. But apart from that, specifically, for me, the most fascinating papers have been things that have been way in the past. Like the first time I read the MapReduce paper was ridiculous. I was like, how did they solve it with something so simple, right? I'm like this is ridiculous. like the idea is so simple, but then obviously it's in the devil's in the details. But just the idea, like how did they come up with it, right? And even HDFS, like from which so many things have formed on top. I mean, those are the papers I still think of as fascinating. But on the more recent side is probably on that side of how do you build machine learning systems, and Google's been releasing a few papers on that, which I really like. I can probably get you the name. I probably don't remember the name right now. So
perfect. Okay.
So
no worries. And I think Dio, that's what Dio was asking. Is it the Google papers? So to your question, yes, Google has some resources.
yeah.
Cool. So it is nearing 5:29. I guess because of the time duration, I guess any additional questions, and any other way, the best way to connect to you if there's any additional questions would be to reach out to you on LinkedIn, right, Kanchana?
Yeah, you can just reach out on LinkedIn.
Perfect. Well, I guess thank you so much for taking the time out and answering all these questions. This was a really nice chat. I really enjoyed it, and I'm sure that others found it very insightful and very helpful as well.
Thank you so much for having me. I really hope my answers made sense. Again, that's the imposter syndrome in me coming up, but I'm going to assume that whatever I said made sense. And of course, if you have more things to chat with me about, just reach out to me on LinkedIn. I'm happy to have a chat.
Perfect. Thank you so much, Kanchana. Really appreciate it. Thank you to everyone who joined in. Take care. Bye, guys.
Bye-bye.